the top stays, the 100 to the 1 stays 100, the bottom doesn't, the top doesn't go anywhere, it just stays 100 to the 1. And where does the 2 go? Swings around, falls through the trap door into the hook there. So basically, it's the square root of 100, isn't it? Because the 2 and the 1, those are both understood, assumed numbers, aren't they? There's nothing surprising about those. Square root of 100, 10, as you know. Is that good? So a half power is a square root. A half power is a square root. So try that one. Let that 4 swing around into the hook. So that 4 swings around, becomes the 4th root of 1 over 81. We good? And then, how do you do the 4th root? You're just saying, what times itself? Well, the top's just going to be 1, huh? What times itself 4 times is 81? You want to use your calculator? Try it out. Just guess. Just take a guess. Try 5. 5 times 5 times 5 times 5. It's going to be way too big.
3.
3 it is. Yeah. You just take your calculator. Right, because 9 times 9 is 81, huh? And that's 2 3s, right? So it's 4 3s is 81. Yeah, 1/3. We good on that one? This making sense? Well, those fractional powers become roots. The denominator swings into the hook. Becomes the index. 3m to the 1/5. So basically, this one's not going to do much. They just want me to rewrite it as a root. That's all. They're saying, use radical notation. Radical means root. So they're saying, hey, write it like a root. That's what they're saying. Make it a root. So the question is, though, we know the 1 is going to stay on the top. No big surprise there. The 5's going to swing around, yes. But is it going to be like this? Is the 5 going to? Are they both going to stay inside, or does the 3 is the 3 stay out here, and it's like that? Which one of those is right? Well, basically, whoever the power is on, that's who the root has to be on. Right? That makes sense? That's reasonable, right? So that 1/5 power, is it on the m and the 3? Or just the m? How do you know? Because there's no parentheses. You're right. You guys with me? Let me make sure this is clear. If I gave you something like 2x to the 3rd with parentheses, that means the whole 2x. That means 2x, 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 right? When the power's on the whole thing. Whereas if I write 2x cubed like that, that just means 1, 2 with 3 x's. We clear on that? Right? If a power is on something, it's only on the immediate thing unless parentheses extend its influence. Huh? Good? So that's the principle we're dealing with back here. This 1/5 is only on the m, huh? If there's parentheses like that, then it would be on the whole 3m, wouldn't it? And then then it would be this answer. The whole 3m would have to be inside the root, but it's not. There's not parentheses. The 1/5 power is only on the m. So when you make the root needs to be only on the m, because that's who the power was on, only the m. See that difference? We good? So it's all about who the power is on. This 1/5 power is only on the m. He's not on the whole thing. He's not on the 3. So if you have parentheses, then it's on the whole thing. Okay, so you can type that into Math Excel. They give you a little special symbol with put the numbers in. It'll be easy for you. Let's try number 4. Try number 4. Try the 1/3 power on minus 64. Can you all see that okay? So minus 64, 1/3 power. So let that 3 swing around. See the parentheses there? So you know that 1/3 is on the whole minus 64. So that 3 will swing around, become the 3rd root of minus 64 to the 1. That's just minus 64, huh? 3rd root, what times, use your calculator, what times itself 3 times comes out 64? 4, and it's going to be negative, huh? Yeah, negative 4 times negative 4 times negative 4. 3 negatives would make negative 64. Is that making sense? Anything I can answer on that? Okay. 16 to the 5/4 power. Let me just move it over here. 16 to the 5/4 power. Want to try that? So let that 4 swing around, right? Let that 4 swing around. You might be able to do the whole 5/4 power thing directly on your calculator. Depends on your calculator. You can figure that out. Great. I'll do it by hand. Let that 4 swing around. So that denominator 4 swings around. 4th root of 16 to the 5th. We good there? Like that. And then, now, how should we work this out from here? I would actually do the 4th root of 16 first. You can do them in either order. You can do the fifth power first or the root, either order. I would actually do the 4th root of 16. Like, what number times itself 4 times is 16? 2, correct. And then do the 5th power afterwards. And go 2 times 2 times 2 times 2 times 2. 5 times 32. We getting that okay? Is that making sense there? Questions? Any I can answer? How we doing? You guys got to give me some feedback here. Okay, so try that one. Let that 4 swing around to be in the hook. Then use your calculator. Or maybe just go directly to the calculator if you know how to do the fractional powers of the calculator. So that 4 swings around. We good to there so far? Right? That denominator swings into the hook. And now, can you do the 4th root of 81? Use your calculator. What? So I would do the root first. Do this part first. Do the power later. Be easier that way, because roots make numbers small. Right? Do the small part first. So take your calculator. What times itself 4 times is 81? Just guess on your calculator. It's going to be 3. Negative's still going to be there. So negative 3. And then you got to do the 3rd power, huh? Right? Because I just did the 4th root part. Then you got to do the 3rd power. Negative 27. We good? This making sense on that?
On that one, it told me that the answer is not a real number.
Oh, you're right. I'm being crazy. Yes. Thank you, Marissa. That one's crazy. Why? What's wrong with that one?
Because when it's the even exponent, it's not a negative.
Yeah. How do you know?
Because when it's odd, it's a negative because the negative times the negative is a positive, and then when you times a positive, it becomes a negative. Oh, a negative times a positive is a negative, but when it's even,
I know what you mean.
Yeah.
You're totally right. You're totally right. Yeah, good. You're right on the money. Yeah, let's think about what's... Okay, remember what square roots are. Let's go back to the basic idea. What's the square root of 9? 3. And why? Why is that? What would you say to a young child who said, why? Because 3 times 3 is 9, right? 2 of them. Okay, so now with that same thought in mind, what would be the square root of negative 9? Can't do it, right? Because nothing times itself twice is negative. Right? Negative 3 times negative 3. 2 negatives, that's not negative. That's back to positive. So that won't go back to negative 9. You might think, well, just do 1 negative, 1 positive. Well, that's not the same thing twice. Remember, roots have to be the same thing. Those are opposites. So you can't do the square root of negative 9, can you? Your calculator give you error. You can try to calculator say error. Right? Is this making sense? So, and what number's in the hook there? I'm just talking about this part. There's just a 2 there, right? So basically, you cannot do. Let me write. It's not possible. It's imaginary. I don't know if you've taken other math class. It's imaginary. But for now, we'll just say can't do it. Can't do it. But what about if it was odd? What about if we did the cube root? Wait a minute. Hold on. What about if we did the cube root of a negative number, like the cube root of negative 8? Can you do an odd root of a negative? Yes. Not for even, but for odd. Why? Why? What times itself 3 times is negative 8? Negative 2. Negative 2, negative 2, negative 2. 3 negatives is negative. Do you see how we can do the odd for negative because an odd amount of negatives is negative? How are we doing? Am I losing you? Let me slow down for a minute. You agree 2 negatives make a positive, right? 2 negatives make a positive, right? But 2 negatives don't make a negative, do they? There's no way to have an even amount of things come out negative. Well, no way to have, an even amount of the same thing come out negative. Right? There's no way to do the 2 root of negative 9. No way something twice is coming out negative. Because 2 negatives would be positive. No way. But you can have something 3 times come out negative. Because 3 negatives is negative. So you see the deal? It's okay with odd. It's not okay with even. So that's the problem. 4 through to negative 3 is not negative 3. That was just crazy I wrote that. Again, I displayed my poll. Otherwise, I would be a genius today. That's craziness right there. That's complete nutso. I should be fired for that. All right, so that's not right. That can't be, right? You can't do something 4 times. And, right, the 4th root, a negative 3 4 times is not negative 81. It would be positive 81, wouldn't it? Right? 4 negatives would be positive, wouldn't it? It's not going to be negative 81. So done. No solution, as Marissa told me. No solution. Or what do they say? No solution? Or not?
It's
not real. Yeah, good. That's a good way to put it. Not real. Yeah, do y'all see that? Is that okay? So what's the rule then? Even for a negative number is not real. There's the rule. Let me write that on the board, too. Keep that up. So that's another good. If you want to add to the main rules here. If you have an even number in the hook and a negative number in the root, that's not possible. That's not real. It's okay for odd in the hook, not for even, right? Because you can't have an even amount of negatives come out negative. They'll always come out positive, won't they? 2 negatives or 4 negatives, that's always going to be positive. So like if you did the 2 root of a negative number or the 4 root of a negative number, no way. Those are not real. Can't do it. But you can do it for odd. So that's what you want to watch out for there. Yeah, they snuck that one in. So 7x plus 5 to the 4/5 power. What are you supposed to do with that thing? What do they want me to do? They say use radical, meaning write it as a root. Make it into root language. So the 5 is going to go where? Into the hook. That's all we're going to do. There's nothing more in this one. 7x plus 5. Now, I have to put parentheses around the 7x plus 5 to the fourth power, and there we go. We're done. That's all they want us to do on that one. That's all we can do. We're just done right there. You good? It's all making sense. All right, how about, can you read number 8 there? 64 to the, oh, now they're bringing in, boy, this is a hard section. All right, I got to add to our rules. So here's some good rules for this whole section. We've seen anything to a fractional power, the b swings around into the root, into the hook, I should say. And we've seen that even, the even, can't do the even. The even root of a negative number, like 2 root of a negative number, or the 4 root of a negative number, is not real. Step 3, we've learned now that negative powers flip the thing to the bottom. The power becomes positive. And then putting it all together, if you have a negative fractional power, it flips it to the bottom and makes it a root. Like that. Both things. Okay, so getting back, what's this one going to do? See, it's got a negative fractional power. So negatives in the power zone. So here's how you want to think about it. There's like 2 worlds in math. There's the base level, like I can make that 64 negative, he's a base. And then there's the power world, like that negative up there. So it's just like society, right? We have regular people, like me and you, and then we have power people, like politicians. It's election time, right? I've never got invited to have lunch with the governor or the president, right? Because I'm not a power player. I'm a regular. So if that helps you think, I'm just being silly, but you want to think about 2 levels there. So negatives on the base level is one thing. Negatives in the power level, that's what I'm telling you in Rule 3. Negatives in the power level flip the whole thing. They do something more powerful, don't they? They don't put a negative in the front, notice. Totally different idea. Negatives on the base, negatives in the power, totally different. More powerful when it's up there. So this negative right here, this answer will not be negative in the end. Negatives in the power do not come out front. They flip the entire thing. See the difference? Very, very different. Just like regular society. All right. So 1 over. It's going to go to the bottom. That's what that negative does. It's just the 1 over. His job is done. He's out of there. Now, what about the 3rd root of 64 to the 5th? You tracking with me? See what happened there? So the negative powers do not put negatives in the front. That's the common mistake. It's totally different. So now, can you finish it from there? Do the root first. Do the cube root. And do the cube root of 64. Like, take your calculator. What times itself 3 times is 64? Get that number. And then do it to the 5th power. So that's going to become 4. And then you do it to the 5th power. We good there? Cube root of 64 is 4. What times itself 3 times is 64? 4. And then do it to the 5th power, and it's something really big. It's 1,024, right? 1 over 1,024. How are we doing? We okay? So negative powers do. No, notice that answer did not come out negative, did it? It's positive 1 over 1,024, huh? So negatives in the power zone are totally different than negatives in the front. Okay. How about number? So I'll go. If you guys good there? Questions on that one? All right, what's the first thing? What does that negative in the power zone do? What did negatives in the power zone do? One at a time. I'm just kidding. Come on, what did negatives in the power zone do? Flip it down, right? They don't put negatives in the front. They don't touch the negative in the front. They have no connection to the negative in the front. Right? The negative in the power zone just puts it all underneath a 1. We good? And then the 2 swings around like that. We good? Good on the first step? We all happy there? I'm happy. Are you happy? Everything's good? Right? All right, what now? Come on, put down those calculators and look at rule number 2. Even negative. Not real. Next problem. Right? We have even in the hook, 2, and a negative on the inside. You can't take the square root of negative 25. What times itself is negative 25? Nothing. Right? How can 2 things multiply to be negative 25? I mean, 2 of the same thing. They can't. You'd have to have 1 negative, 1 positive. You'd have to have the same thing twice, making negative 25. Right? Remember that rule? Even, you recollect they fooled me once. They're going to fool me again. Right? Even root of a negative, not real. Done. Now, if that was odd, we would have gone. If that was a third root, I would have gone forward. But even root, we stop. Okay. And basically, they want me. What they're saying is, you really do have to read the words, I should say, on these because they want different things at different times. They want positive exponents, positive powers on this one. So they don't want me to leave that power. See how it's negative? All right. So what do negative powers do? It flips it, right? So this negative power. Now this one's already on the bottom. You with me? Like what if I had x to, let me just make sure we're clear on this. What if I had x to the minus 2? What would that do? 1 over x to the positive 2, a regular 2, right? You with me? It'd flip it down. We good? So I often say, the way I say it is like it's negative, it's unhappy. It's unhappy at its job. It's unhappy at its job. It's negative. It's unhappy. It wants to jump to the other side. Then the power becomes positive. That works. That's the rule. Okay, so what if it started on the bottom? Like what if I had 1 over x to the minus 3? What if it started on the bottom and it was negative? What's it going to do? Jump to the top, huh? And then become positive or just regular, x to the third. Everybody see that? That's what rule number 3 is saying. Negative powers, they're negative. They're unhappy where they're at. They want to jump to the other side. Okay, let's get back to this one now. This is a P, if you can see this down here, to the it's got a negative power. It's on the bottom with a negative power. So what's it going to do? Jump to the top, right? The whole thing will jump to the top and it'll become P to the positive 6, 7. On the top now, not on the bottom. Everybody see what happened there? Negative powers are negative where they're at. They're unhappy where they're at. They jump to the new job. Jump to the other side. Right? So there's a negative power at the bottom. It jumps to the top, and then the power becomes positive. Isn't that good? Power becomes positive. So positive 6/7, like that. And then we're done. Now you might, well, if I was you, I'd be like, well, don't you do the 7 swinging around the root thing? No, they're simply not asking me to do it on this one. That's why you want to read the words. You tell what they want. All they say is write with positive powers. I did. Those powers positive now. So they want different things on different questions. See what I mean? You guys kind of pay attention. They change up what they want. So we're just done right there. Are we okay? That makes sense? All right, try number 11 then. What are we going to do on that one? Well, we should probably add to our rules. Do you know what the rule is there on number 11? Let's go back and add to our rules. So I'm going to add, I'm running out of room here. Rule number 5. Well, yeah, okay. Rule number 5. X to the A times X to the B is X to the A plus B. Can you read that down there? So when you're multiplying same bases, I got to get a little more room here. When you're multiplying same bases, you add the powers. Everybody see that? So when you're multiplying same bases, you add those powers. So x to the a times x to the b. Same bases multiplied, you add powers. So do you remember that rule? So, I bet you know that one, right, from earlier stuff. You know, like x squared times x cubed. We talked about that today, didn't we? That's x to the fifth, because it's 2x's and 3x's. All right, so with that in mind, where I'm getting... All right, so number 11. So we have b to the 1/3 times b to the 4/3. So same bases multiply. What should we do with those powers? According to rule number 5, same bases multiplied. What do the powers do? Powers add. You just use one of those bases and you add the powers. Is that good? Is that making sense? So, and then what would that be? 5/3? Done. That's all they want. How are we doing? Am I losing you? Is this making sense? Too many rules? Yeah.
Is there a way that the denominators are not the same? You have to do
Yeah, yeah, look at number 12. Yeah. Got to get common denominator and add them. You were anticipating, weren't you? Yeah, yes, there it is. Right? So everybody says you got to add the powers. So same bases multiplied, powers add. So try number 12. Let's do number 12. It's 3 to the 3/5 times 3 to the 1/10. You've got to add 3/5 and 1/10, don't you? You got to add those powers. Same bases multiplied, add those powers. So how are we going to add those powers? Common denominator. Top and bottom by 2. So this becomes 3 to the 6/10 plus 1/10, 3 to the 7/10. That making sense? Anything I can say to help? So same bases multiplied, you add powers. Same bases multiplied, you add powers. See how I just did rule number 5 there? Questions on that? All right, so let's try. Oh, and then they're going to give me another one. Boy, they're just... Okay, so this one's not real. Let me go back. So what are we doing now? Yeah, let's just do it that way. What does a half power do on... Yeah, we don't need a new rule here. I'm mistaken. We can just do this with what we already know. What have we learned about a half power? What is a fractional power? It's still on the board. Rule number 1. Rule number 1. What does a fractional power do? Swings around, Scooby-Doo, becomes a root, right? You with me? So that fractional, but you put anything to the half power, right? That 2 will swing around. So 2 root of 16u squared. And the 1 power isn't doing anything, so I ignore it. This 1 power here, anything's to the 1 power, right? Y'all with me? See what I did there? And so then what is that? What's this, the 2 root of 16u squared? Yeah, what times itself twice is 16u squared? 4u. Done. How are we doing? Yeah?
If that wasn't a 1.
Yeah, if that wasn't a 1, then I would have to power the 16 and power the u squared by whatever the power was. Yeah. We good there? Is that making sense? So fractional powers swing around, don't they? Fractional powers swing around like that. All right, let's try number 14. What are we going to do on 14? Oh, something difficult. Okay, so yeah, let me write out here. Rule number 6. If you have one base to a power and then another power, those powers multiply. One base to a power with another power, those powers multiply. So one base, two powers, multiply. Another way I've said it is powers outside parentheses multiply powers inside. Maybe that'll help too. So one base, powers inside, outside parentheses, multiply. Versus rule 5, two bases, separate, powers add. See the difference? So, let's go back to it. By the way, I don't want this to be magic for you. Hold on for a second. Well, just think with me. Just be real. 2 squared times 2 cubed. I want you to, just see that these are real. They're not just sitting around making up weird stuff. This is true. 2 squared times 2 cubed. What does that equal? Let me do multiple choice. You guys up for a multiple choice question here? All right. 4 to the 5th, 4 to the 6th, 2 to the 5th, 2 to the 6th, none of the above. Are we ready? We're going to answer. We'll do multiple choice. We'll take a survey. This is Family Feud here. Survey says. You ready? I would say to somebody that said that, I would say, well, rather than just tell them they're wrong, I want them to see they're wrong. I would say, what does 2 squared mean? Let's just forget about all the fancy math rules. What is 2 squared?
4.
Right, I mean, it's 2 2s, which you're right, it's 4, but how about we just keep it really simple? It's 2 2s, right? Nobody's going to argue with that. And what is 2 to the 3rd? 3 2s, right? So what do we got there?
2 to the 5th.
Yeah, we don't got 5 4s. We got 5 2s. Right? So Marissa was right. You guys were right. The majority was right. So, everybody's seeing that. That's true. That's not just like my opinion or something, right? It's true. It's what's right. It's true, right? So, what is the rule we're seeing here? That is rule number 5. That is saying when same bases multiply, you don't actually multiply the 2s. You just add the powers. Why? Because it's true. It's 5 2s, not 5 4s. Right? Now, with that same thought in mind, let's try a new one. What if you go, whoops, I tried to change the color there. What if you go 2 squared cubed? What happens there? Now, I want truth. I don't want to just like my opinion, Give me a true reason. How about this? What does a 3 mean on anything? It means 3 of those, right? Doesn't it mean that? Doesn't it have to mean that? That's what a 3 means on anything. 3 of them. These are repetition symbols, aren't they? These little numbers in the upper right-hand corner, they're just shorthand repetition, aren't they? Okay. And so how many 2s you got here altogether? 2 of them here. 2 of them here. 2 of them here. 6, right? Isn't that 2 to the 6th? So what's the rule here? What should I have done? What's the shortcut? What should I have done with this 2 and 3? Multiply them. That's the new rule I'm giving you, rule number 6. You see that? One base, the 2 powers multiply. Because that's true. 2 bases, the powers add. Do you see that? Does that make sense? Okay, let's get back to the question. So, here we go. We've got, let me make it a little bigger here. I think I have it here. Let me see. I don't know if I did or not. Yeah, good. There it is. All right. So x on the top, I have x to the 7th to the 1/2. And the bottom, I'll just leave the bottom for now. Now, what am I going to do on the top? This is one base, 1x, 2 powers. What have we learned happens? You got 1 base, 2 powers. What do those powers do? They add or multiply? Multiply. So it's going to be x to the 7 times 1/2. Let's leave the bottom as it is for now. Right? We good there? Now, how do you multiply 7 times 1/2? Yeah, you make that look like a fraction, put it 7 over, right? Whenever a whole number interacts with a fraction, put it over 1. And then that's just going to be, just straight, right? Top times top, bottom times bottom. X to the 7 halves over x to the 11 halves. We good so far? I just multiplied on that top, right? Just multiplied straight. Top, top, bottom, bottom, right? Because that's what the rule says. One base, one x, two powers. Powers, how about the parentheses? That's better. Powers outside parentheses, multiply powers inside parentheses, right? This guy multiplies that guy. Powers outside parentheses, multiply powers inside parentheses. Okay, so now what? Now what do we do with this thing? We would like to, do you remember? Actually, I need to give you a new rule. There's so many rules tonight. Rule number 7. If you have two powers like a over b divided, that is 1x with the powers what? Here, look back at Rule 5 with me. Look at Rule 5. Two bases multiply, powers add. So two bases divided, powers subtract. Okay, do you remember that? Rule. Powers subtract. So rule number 5, two bases times powers add. Rule number 7, two bases divided, powers subtract. I want that to make sense for you, not just be some rule, because you'll use it better if it makes sense. Let me just show you again how that makes sense. What if I had x to the 5th over x squared? Think about what that really is. Isn't that 5 x's? And isn't that 2 x's? And what can they do? Cancel, cancel. What do you got left? 3 x's. See how subtraction's the right thing? Does that make sense? It's just true, isn't it? All these rules are just following what's true. Now, what if the bigger power was on the bottom? What if you had like x, I don't know, to the 3rd over x to the 4th? What's that going to do? 3x is on the top, 4x is on the bottom. Where's the extra x? On the bottom. Because there's more on the bottom. Or negative, you're right. But we don't want negative power, so let's just do it this way. Everybody with me on that? So if the bigger power's on the bottom, the leftover's on the bottom. If the bigger power's on the top, the leftover's on the top. Right? When you write x cubed all by itself, that means over what? That means top, doesn't it? Right? Y'all with me? So they always subtract, right? 4 minus 3 is, this is x to the 1, really, huh? They always subtract, but wherever the bigger power is, that's where the leftovers end up. It's like a little canceling, because they cancel out. Okay, so getting back to it. What do I do with these powers? Divided, I'm going to subtract the powers, aren't I? Where's the bigger power? Top or bottom? Bottom. So where's the leftover answer going to be? On the bottom. It's going to be 1 over, subtract the powers, 11 halves minus 7 halves is 4 halves. Everybody see that? Let me write it slower. 11 halves minus 7 halves is 4 halves. And what is 4 halves? X squared. There it is. That's 1 over x squared. Did you track with that? So when you're dividing, you subtract powers, and wherever the bigger one is, that's where the answer is on the bottom. 11 halves minus 7 halves, 4 halves, x squared. Questions on that? That good? We're getting a lot of rules here. All right. I'm going to move on if you're good. Yeah, what's, here, let me make it bigger for you. Z squared x, 1/4 power out there. On the bottom, z to the minus half, x to the half. Okay, so that, let's start with that power outside parentheses. So you can do this one. You just got to follow the rules carefully. So the power outside parentheses, what is that going to do? So rule number, whatever it is, 6, tells us the powers outside parentheses multiply powers inside parentheses. Right? Parentheses mean multiply. So this 1/4 right here is going to go boom and boom. It's going to multiply both those powers inside. So we're going to get what? We're going to get z to the 2/4 x to the 1/4. Are we good so far? And the parentheses are gone. So that's always what happens when you have powers outside parentheses. So powers outside parentheses multiply powers inside. Does everybody see what happened? That 1/4 multiplied the 2. Why did the 2 go to the top? It's 2 over 1. Right? Any whole number 2 is 2 over 1. Right? Is everybody good so far? Now, what should we do from here? 2/4, I can just reduce that to be a half. Right? Let's just do that right there. This right here, this is just a half. 2 over 4, you can just reduce it like a normal fraction. 2/4 is a half. Okay, now negative powers is the next order of business. See how this is a negative power? What if we learn negative? They're negative, they're unhappy where they're at, they're going to jump to the other side, aren't they? So this guy's going to jump up to the numerator. Everybody else is happy. Everybody else is positive powers. They're staying put. Nobody else is jumping. Just that guy. He'll jump up to the top and he'll become a positive power. Z to the positive half. So it'll become Z to the positive half right next to the other Z to the half. The x to the 1/4 is up there all over x to the half on the bottom. This one's getting ugly. I'm going to rewrite it. It's just getting too messy. So z squared x, one more time. We'll back up. We're almost done. And z minus half x half. Okay. So here we go. So again, one more time. Powers outside parentheses multiply powers inside. It'd be good to see it again. That'd be z to the 2/4 x to the 1/4. Good to there so far? Powers outside parentheses multiply powers inside, and the parentheses vanish. Step 1 again. And then the negative power on the bottom. He's unhappy. He's going to jump to the top. Everybody else is staying put. So he'll become, bring him over here. He's going to become z to the positive half right next to the 2/4. And x to the 1/4, and the x to the half is still in the bottom. And I'm going to make that 2/4 into a half, right? Everybody see that step? Okay, what now? What needs to happen now? What are these guys going to do? Yeah, if that was like z to the 3rd times z to the 5th, it'd be z to the 8th, wouldn't it? Same bases, powers add, right? So it's just going to be z to the 1. Half and half makes 1 whole, doesn't it? So it's going to be z to the 1, half plus a half. Is that good? Same bases, powers add. And then what happens? Same bases multiplied, powers add. And then what's going to happen with these two x's? They're going to subtract. How are we doing? I feel like I'm completely losing you at this point. You know, the hard thing is they assume you basically know these rules already, and now you're just doing them with fractions. But I can see that you don't already know these rules. And that's always what's hard in algebra, is it's building, 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 and they assume you know Math 61. Math 61 is all these rules without fractions. Like, you know, but if you're not fresh on those, then you try to learn the rules and the fractions. It's hard. So that's what's hard. So this, just simply put, this, if you want to learn this and do well, you got to spend hours of your life. I had to too. So let me, I don't know if that's encouraging, but I want to tell you the truth. So I can see this is new for many of you. Or you're not clear already coming in on those rules. That's okay. You can master it, but not without time. You're going to have to go back over and over and over. Watch these YouTubes, do these problems again. You can go back in, it'll give you new ones, it'll change the numbers, do them again and again and again and again and again until you have it. That's what it takes. We're learning Chinese here. It doesn't come to the casual, right? You got to give it that. All right, so with that said, I feel the pressure of time. I want to get on to the hard stuff for you, but I know it's all hard. So same basis, right? So rule number 5, side by side they add, right? Oh, I never wrote up rule number 7, did I? I never wrote vertical divided, they subtract. So these guys add. These guys, the half and the fourth, are going to subtract. Remember we did it back here? Remember that? Like 4 minus 3 leaves 1 in the bottom. Remember when they're vertical, they subtract. When they're side by side, they add. So these guys are vertical. They're going to subtract. Which one's bigger? The half or the fourth? Which is more pie? I had a half of the pie or I had a fourth of the pie? Half of the pie is more pie. The bottom's bigger, which means the answer is going to end up on the bottom. A half minus a fourth. Y'all with me? You getting that? So you can go over this again later. So side by side, the z half, they add. Vertical, they subtract. But wherever the bigger one is, that's where the answer is going to end up. So then what's a half minus a fourth? Yeah, because a half is really 2/4. 2/4 minus 1/4. 1/4. We're finally done with that awful problem. There it is. All right, so a couple really important rules to get down straight there. So in the beginning, powers outside parentheses multiply powers inside. Negative powers jump. And then side by side they add, vertical they subtract. So you should do this problem 10 times over with asking the machine to give you different numbers until you can do it flawlessly. And then you'll start mastering those rules. That's what it takes. That's what I had to do. We good? Anything else I can answer on that? So basically they want me to... What do they want me to do? Well, let me use the rule. Let me undo the fractional power rule. Can you go backwards to the fractional power rule there? You know what I'm talking about? That's the same thing as x to what over what? What number over what number? What fractional power? 2 over 4, right? We all tracking with that? I'm just kind of doing the rule backwards here. Right? 2 over 4. Because remember that 4 swings around, gets in the hook, right? I just kind of did that rule backwards. Good there. And now, what can you do with 2/4? We can always reduce fractions. We always do that whenever we can. So that becomes a half. I think that's the answer they want. They might want me to... All right, good there. So now that I simplified that fraction, I can swing it back. The 2 will go back, and it'll be the 2 root of x to the 1, which is just the square root of x. How are we doing? Did you track with all that? So I just did those fractional power root things. They're just having us do those forwards and backwards to really master those. So that 4 in the hook swings back. Right, you can always go denominator to hook or hook to denominator. Either way, depending on what you're trying to do at the moment. They're the same thing, right? To be in the hook is to be in the denominator. And then 2/4 is a half. Swing it back into a root. And that's the 2 and the 1 are understood, aren't they? That's why that last step is just regular root. Because the 2 and the 1 are understood. You don't need to write it. All right, let's try number 17. 8th root. That's awful. Is that a nice... I don't know it off the top of my head. Is that a nice number? Like, is that like, I don't know, 3? 3 to the 8th power. Is 3 times 3, 8 times 65, 61? Yeah. It is. Thank you. All right. So that's 3. Good. So we handle that. So that's 3. 3 times itself 8 times. And you guys know, do you guys know how to do the power button on your calculator? You have a power button. I'm glad to show you after class, like 3 to the 8th power, or you might have like an X to the Y button. Depends on the calculator. So you can check it quick that way. 3 to the 8th power is 6561. So we go, all right. So we got that. The 8th root, it's going to be 3. Now what do we do about the X stuff? It's X to what power? X to what power? What's it going to be? What can we do with the number in the hook? Where can the number in the hook go? Denominator or hook. They're the same thing, huh? You guys getting that rule? Sorta? Maybe not so much? Let me write that rule again. A over B. Remember, a fractional power can go to the hook or back and forth. So fractional power, that can go to the root or to the denominator. Anytime you want, it's the same thing. So I could take that 8 and swing it there, and it'd be 4 over 8. You tracking with me? Hook, denominator, same thing. And then that is 3x to the half, and that is 3 root x. I just reduced 4/8 to be a half. Is that making sense? So they keep pushing us on that rule. A number in the hook becomes the denominator. How are we doing? Am I doing the Charlie Brown teacher right now? 1, 1, 1, 1, 1, 1, denominator, 1, 1, 1, hook. Right? Are you getting that rule? I know you've been hearing me for 2 hours here. That's why I broke into soccer story. I thought you did live and things like that. All right, Bruce, you have to share an exciting soccer story next time. All right, so denominator hook, denominator hook. Everybody getting the hang of that? You can swing back and forth, either one, depending on what you're trying to do at the moment. They're the same thing. To be in the hook is to be in the denominator of the power. To be in the denominator of the power is to be in the hook. There are 2 ways of saying the same thing. Right? We good? That makes sense? It's like saying faster, quicker. They're synonyms for the same thing. So, I took that 8 from the hook and I put it in the denominator. Why? Because then I can reduce it. 4/8, that's just a half. And then I swing it back to be root. Let's try that same thing here on number 18. So number 18 has the 4th root of x squared y squared. So where am I going to put that number in the hook? That 4 in the hook. Where's it going to go? Denominator, right? Because to be in the hook is to be in the denominator. So it's going to be x to the 2/4 y to the... He becomes the denominator for both. Because he was the root for both. Everybody see that? So it becomes the denominator for both because he was the root for both. And then what can you do with those fractions? Yeah, both those reduce, huh? X to the half, y to the half. And then what's that? That's just the square root of xy. Right? They're both, half power is just a normal root. Is that step making sense? So we simplified that. Here, I can put it right here. That's just the square root of xy. All right, I'll move on. We got just a couple into pre-calc. Like pre-calc students have trouble with all these rules. So, okay. 5 in the hook. So if there's anything I want to give you before the night's over, we only got 5 more minutes before the night's over. To be in the hook is to be where? Denominator. So anything in the hook is in the denominator. So that 5 in the hook is 1/5, because that's 5 in the denominator. And there's no other power showing, so it must be 1, huh? Times, all right? What about the next one? That 3 in the hook goes in the denominator. Y to the 2/3. Good? Now, what they want me to do is they want me to make it a single radical expression. Remember the rule? There's so many rules, I know. Same bases multiplied. Side by side. How about if I say it that way? Side by side, what do those powers do? Add, yeah. So that's 1/5 plus 2/3, isn't it? One base, one y. Side by side, powers added, right? And now how do you add 1/5 and 2/3? Common denominator, right? Common denominator. So multiply top and bottom by 3, top and bottom by 5. So this is y to the 3/15 plus 10/15. So that's y to the 13/15. Everybody see what happened there? Right? So those numbers in the hook become denominators. And side by side, they add the powers. Common denominator, 13/15. Last step, they want me to make it back into a root, right? Single, radical means root. Radical is their word for root. Radical is not a political extremist, although it is in that context. But it's also a root. So radical is a root. So y to the 13/15. They want me to make it back into a root. You know, where's the denominator go? Into the hook, right? 15th root, y to the 13. There it is. I combined those two roots into one root. See that? Can you do the same thing on number 20? So number 20, those are all denominators, aren't they? 1/6, 1/5, 3/10. Right? Those hook numbers become denominators, and then add those up. Add those up. We call them denominators. And what's the common denominator going to be for 5, 6, and 10? Third. Make them all into third. All right, so I'll try to go to fresh screen for number 20 here. All right, so this is going to be y to the 1/6, y to the 1/5, y to the 3/10. And side by side, they all add up, don't they? So it's going to be 1/6 plus 1/5 plus 3/10. Good there. I'm going to make that bigger. Right, side by side, powers add. 1/6, 1/5, 3/10. And now, to get them to add, we multiply top and bottom by 5, multiply top and bottom by 6, multiply top and bottom by 3. And that equals y to the 5/30 plus 6/30 plus 9/30. And that is y to the, I don't know, what's that, 20/30? Which is just reduced. We always reduce fractions. So that's going to be what? Yeah, let me bring it over here. That is y to the 2/3, isn't it? And last step, they want it a single radical. Not a political extremist, but a root. They want me to make it a root. That 3 swings around, third root of y squared. There we go. Is that making sense? We're getting a little more comfortable with those rules? Really, it's just about, it really is about practice. Math is so much about practice. I was doing my daughter's taking physics right now, and so I'm helping her with physics. And we went through the homework the first time, and it was so hard. I'm a little rusty on physics. I took it way back when. And anyway, so I helped her with it. It was really hard. And then her and I went back over it before she took the exam a couple weeks ago. And like second time, it was like, oh yeah, that's right. It just boom and boom, and it just felt like 10 times easier second time. That's math and science. You really have to do the homework and then look back over it again. And your mind will start grabbing it. It really will. But you have to put in that second look. Things will get amazingly easier. Like I was like, why do we have so much trouble? Both my daughter and I were like, why does it seem so hard at first? You just move the thing and do the thing, boom, there's the answer. It was coming out. It's just how our brains work. We need that second look at math especially. So work through this a couple times.